So hey guys, this is the first video I've uploaded in a while because my mom took away my phone because I got bad grades. Fun. But anyways, that's not the subject of this video, and frankly I find it incredibly annoying when YouTubers say something along the lines of, "Oh, sorry guys, I just couldn't upload a video because I was taking a vacation." I'm gonna be completely frank. Yeah, I'm not sorry at all, because I'm terrible at making videos, so it's really no problem. Okay, now to the actual subject of this video, which is to talk about something that's kind of confused me for a while, which is having bullets in a vacuum barrel, and having that barrel infinitely long and frictionless. So the idea is that the way bullets work is that when the compound, generally combination of nitrocellulose and nitroglycerin, which is so that's synthetic gunpowder, is ignited, it detonates and creates a lot of gas, and that gas has a pressure because it's inside a volume, which is not equal, and that pressure is not equalized with the pressure that's in front of the bullet, meaning that there's an unbalanced force pushing the bullet forward. What this means is that if you don't have any pressurized force in front of the bullet, then the bullet will just keep accelerating, because there will always be an unbalanced force behind the bullet and not in front of the bullet, because there is no force in front of the bullet, because there is no pressure. Unlike in atmosphere, where eventually if you have a really long barrel, eventually it equalizes, and then you don't have any acceleration for an instant in time, and then it starts decelerating because the pressure in front of the bullet is larger than the pressure behind the bullet. All in all, this means that as you actually accelerate, as you have the bullet in the long barrel in a vacuum, there will always be more gas particles behind the bullet. And if you have a really good particle, for example helium, what you can have is even if it gets so sparse where it's unlikely for a particle to hit the back of the bullet at any time if you're using normal particle physics. However, if you consider it as a wave, like helium atoms, also known as alpha radiation, well, sort of, what you get is a wave where one of the only places where the atom can be is behind the bullet, because that's how physics dictates where it should be. I did the math of this, and what ends up happening is that the acceleration will always approach zero but never reach it. Turns out it's a logarithmic function. Well, sort of. Well, not a logarithmic function. What is a logarithmic function is the velocity, but the acceleration ends up looking like an asymptote, but actually a little bit shifted, so that what ends up happening is that you have an initial acceleration, which is where the asymptote actually intersects the vertical axis, and then you have the acceleration constantly going downwards and downwards and downwards, where t, which is time, is a limit as t approaches zero, meaning that you will always have it accelerate, but as time goes on you get sort of a law of diminishing marginal returns because of the asymptotic feature of the acceleration. Now again, I did the math myself, but I don't really feel like you would appreciate it, because it's really not very special, and I feel like you could probably do it on your own if you're that interested. It's really just a extrapolation of ideal gas law. That's why I'm using helium, because PV equals nRT. You have a constant amount of moles of gas. R is constant, and I don't take into account temperature because I don't want to work with it because temperature will fluctuate, and it means that I'll end up with a very strange looking graph. So I assume that temperature is constant, and pressure is actually just to get force out of pressure. What you do is you multiply you multiply the area of the back of the bullet by the pressure, because I did it by pounds per square inch, because you can turn that into newtons per square meter. And then I had to do other stuff and change the constant, which is R. So in all totality, what you end up getting is the volume increases because it's area of the base of the bullet times the displacement, and then the pressure is just equal to the. So you just end up with pressure is equal to nRT over V, and V is area of the base times displacement, and displacement is also known as V x naught plus V naught equals 1/2 AT squared plus something else, because calculus, it's painful. And so I don't want to go into the depth of math, but it's just something interesting that I found, and a little bit strange. So yeah. Oh yeah, guys, one more thing. You may have noticed that I changed my face in this video, so now you can see my face, because it wasn't very exemplary of my emotion at that time. So, bye.